Welcome back, everyone, to the deep dive. Today, we are diving into SQL.
Yeah, diving deep into like really foundational SQL concepts for building, good databases that'll actually work the way you want them to.
Exactly. And to make sure they're efficient and reliable.
Absolutely.
So, we've got all this material that focuses on three really key things:
Yeah,
data types, constraints, and normalization.
exactly. And I think the thing we want to try to do today is extract, like, what's the most essential stuff to know from all this?
Yeah, how can our listeners use this to actually design better databases? To
Exactly.
get that data integrity and optimize the performance of their databases, we're going to try to really distill it down into something useful.
Yeah, we've gone through and pulled out all the kind of most important points so that, it's not overwhelming.
Exactly. Just the most important stuff about data types and constraints and normalization.
Yeah.
All right, well, why don't we jump right into it, starting with data types.
Okay, so with data types, every single column in a SQL table, you have to define a data type. And that data type says what kind of data that column can hold.
So is this kind of like saying, what kind of container are we going to put this information in?
Exactly. And choosing the right data type is really important for both storage and kind of the accuracy of your data.
Right. If we're storing numbers versus text, those need different containers.
Exactly.
So let's go through some of the common ones here.
Okay.
So we've got int, for example, in the numeric types.
Yeah, so int is for whole numbers, integers, right?
Okay.
So if you're storing, number of items like 42.
Exactly, 42 apples.
Yeah.
Okay, so then we've got decimal.
Decimal. So
Wow.
decimal is interesting. It stores exact numeric values.
Yeah.
And has two parameters that you specify: precision and scale. So precision is the total number of digits, and scale is the number of digits after the decimal point. So if you had, say, decimal 5.2, you could store a value like 123.45.
Right. I see. So the 5 means 5 total digits.
Exactly.
And the 2 is 2 digits after the decimal.
Yeah. And this is really important for things like, financial systems.
Right. We can't have rounding errors.
Yeah, exactly. If you're dealing with money, you don't want approximate values.
Got it. Okay, and then float is, I guess, similar. It's also for numbers, but it's for approximate floating point numbers.
Exactly. It's for, like, scientific applications where you might not need perfect precision.
Okay. So moving on then from the numeric types to character types, we've got varchar.
So varchar is for storing strings of characters, and it has a length that you specify. So like varchar 100 would be able to store a string up to 100 characters, and it only uses the space it needs. So if you're storing a name that's 20 characters, it's only going to use 20 characters of storage,
Got it.
which is different from SWAR.
Or sure is fixed length.
Fixed length. So if you
Yeah.
have sure, it's always going to use 10 characters of storage, even if the value is shorter.
Got it. Okay, and then text T, I guess that's for longer blocks of text.
Yeah, like if you're storing a whole article.
Got it. Okay, and then we also have date and time types. We have date, which stores dates.
In a YYYMMDD format.
Okay, and then time.
Time for storing the time of day.
Mm.
So that would be like HHMSS format.
Got it. And then date time is both of them together.
Exactly. So if you want to store a specific point in time, you'd use date time.
Okay, perfect.
And then we have Boolean.
Boolean is for true or false values.
Exactly.
And I guess last but not least, we have binary types.
Yeah, like BLOB, which is binary large object. You'd use that if you're storing things like images or audio files directly in the database.
Okay, cool. And we've got a great example here. If we were making an employees table, we could have an employee, and that would be an INT. We could have first name, last name is varchar, set those to 50.
Correct.
Then we could have a hire date, which would be a date, and then maybe a salary, which would be a decimal, and we'd set, the precision and scale appropriately. So this is a good example of, how you'd actually apply these data types.
Yeah, this is what it would look like when you're actually creating a table.
So, beyond just, being able to categorize the data, why do these data types really matter?
Well, they're really important for two main reasons. The first is data integrity. By defining these data types, you're basically saying what kind of data is allowed in that column. So it prevents you from accidentally putting text into a column that's supposed to be numbers.
Right. So if I was trying to put the letter A in for an employee ID, it would say, no, you can't do that.
Exactly.
Okay.
And the second reason is that it helps with storage and performance. If you choose the right data type, you can actually save space and make your database run faster.
Okay. So give me an example of how choosing the right data type might, improve performance.
Sure. So like if you have a column for age and you know the age is never going to be greater than 100, You could use a small int instead of an int. And that would save you space because a small int uses less storage than an int.
Okay, makes sense. And same thing with varchar, right? If you are using sheetchar for something where you don't actually need that fixed length, it's going to be less efficient.
Exactly. Varchar will dynamically allocate the space it needs so it's more efficient.
Okay, so a good takeaway here, a good pro tip, I guess, is to always try to choose the smallest data type that you think is going to work, because that's going to save space and potentially make things faster.
Exactly. Always choose the smallest data type that fits your data.
Okay, so we've got our data types. We know what we're going to put in there. How do we make sure that the stuff we put in there is accurate?
Well, that's where constraints come in. Constraints are basically rules you can apply to your tables to make sure the data is consistent and accurate.
Okay, so, we've chosen the type of container. Now we're setting rules for what goes inside the container.
Exactly.
Okay, so what are some of the main constraints that people should be aware of?
Well, the first one is the primary key. The primary key uniquely identifies each row in a table.
Okay, so every row in the table has to have a different primary key value.
Exactly. And it can't be null. So, a common example would be like a custom id in a customer's table.
Okay, so every customer would have a unique customer ID. Got it.
Exactly. And that makes it easy to find and reference specific customers.
Okay, that makes sense. So what about when we have, data spread across multiple tables and we need to kind of link that data together?
That's where foreign keys come in. A foreign key is a column that references the primary key of another table.
Okay, so give me like a real world scenario for that.
Sure. So, you might have an orders table, and each order is associated with a customer. So you would have a customer column in the orders table, and that would be a foreign key referencing the customer in the customers table.
Okay, so we can link each order to a specific customer in the customers table.
Exactly. And that makes sure that you can't have an order for a customer that doesn't exist.
Okay. And then we also have unique constraints. So unique constraints, they just make sure that all the values in a column are unique.
Yeah. So, for example, you might have an email column in a user's table, and you would want to make sure that every email address is unique.
Right. Makes sense. And a unique constraint, it can be null, right? Like you could have one null value,
Exactly.
okay, which is different from a primary key.
Right.
Okay. And then we've got, not null. That's pretty self-explanatory. It just means a column can't be empty.
Yep. So, for example, if you have a product name column, you probably want to make sure that's not null because every product needs to have a name.
Exactly. You can't have a nameless product.
And then finally, we have check constraints. Check constraints are really powerful because you can actually define specific conditions that the values in a column have to meet.
Okay. So what would be a good use case for a check constraint?
Sure. Like, if you have an age column, you could use a check constraint to make sure that the age is always greater than or equal to 18.
Okay. So if someone tries to put in an age less than 18, it would reject it.
Exactly.
Okay. So these are like the main constraints that we have. Why are these so important? Why should our listeners really care about using these?
They're important because they prevent bad data from getting into your database. Like, foreign keys prevent orphaned records, check constraints make sure values are within a certain range, and so on. It just makes your data more reliable.
Yeah, they're like the rules of the road for our data.
Exactly.
And a good pro tip here is to think about how you can use these constraints to actually enforce business rules.
Yeah. If you have rules in your business, try to encode them in the database's constraints.
Okay, perfect. So we've got our data types, we've got our constraints. Now let's talk about how we actually organize all this data.
That's where normalization comes in.
Mhm.
Normalization is basically the process of organizing your database to minimize redundancy and improve data integrity.
Okay, so less redundancy, so we're not storing the same data multiple times.
Exactly. And it makes the data more accurate and easier to maintain.
Okay, so I'm seeing here that we have these different levels of normalization. First normal form, second normal form, third normal form. What's the deal with that?
Yeah, so those are increasing levels of how strictly you apply the rules of normalization.
Okay, so first normal form is the most basic level.
Exactly. So with first normal form, the main rule is that each table cell should contain only a single value. So you don't want to have a cell that contains a list of things.
Okay. And, a good example here, from the material is you might have a student's table and there might be a column for the subjects that they're taking.
Right. And if you put multiple subjects in that one cell, That would violate first normal form.
Right. Instead, we'd want to make like a separate table that links students and subjects.
Exactly.
Okay, so first normal form is all about making sure that each cell has a single value.
Right. And then second normal form builds on that.
Okay.
It says that the table should be in first normal form, and all the non-key columns should depend on the entire primary key.
Okay, so this is getting a little more complex. What's a non-key column?
A non-key column is any column that's not part of the primary key.
Yeah.
So in our students table, the studented would be the primary key.
Right.
And then any other column, like the student name, would be a non-key column.
Okay. And so second normal form is saying that all those non-key columns have to depend on the whole primary key, not just part of it.
Exactly. Like if you had an orders table with ordered and produced as the primary key, and you also had a column for product name, that would violate second normal form.
Okay. Why is that a violation?
Because the product name only depends on the produced, not on the ordered. So you should really move product name to a separate products table.
Got it. So we're like splitting the data up so there's less redundancy.
Exactly.
Okay. So we've got first normal form, second normal form. What about third normal form?
Third normal form is even stricter. It says that the table has to be in second normal form, and all the columns should depend only on the primary key, not on any other non-key columns.
Okay, so we can't have like chains of dependencies between columns.
Right. So like if you had an employees table with employed as the primary key, and you also had columns for departmented and department location, that would violate third normal form
Okay, I'm not quite seeing why that's a problem.
because the department location actually depends on the departmented, not on the employed. So you should move department location to a separate departments table.
Got it. So each piece of information should depend directly on the primary key and nothing else.
Exactly.
Okay, so we've got these three levels of normalization. I guess, why is normalization so important?
Well, as we said before, it reduces redundancy, which saves space and prevents inconsistencies. It also makes the data easier to update because you only have to change it in one place. And it just makes the database overall more logically organized, which makes it easier to work with and understand.
Okay, makes sense. But we've got this pro tip here that says to be careful about over-normalizing.
Yeah. Normalization is good, but sometimes if you go too far, it can actually make your queries more complex and slower.
Okay, so we have to find that sweet spot.
Exactly. Balance is key.
Okay. Well, why don't we go through a real-world example here?
Sure. So one example that we have is an online bookstore.
Okay, so we're designing a database for an online bookstore. What would that look like?
Well, you would probably have a table for books, right?
Obviously.
And that would have columns like the book kid, the title, the publication date.
Okay, makes sense. And then what else?
And then you'd have a table for authors with columns like authority and name.
Okay, so one for books and one for authors. And then I guess we'd need a way to link those together.
Exactly. So you'd have a third table called book authors, which would have columns for booked and authority. And this table would basically link books to their authors.
Okay, so if a book has multiple authors, it would have multiple entries in this book authors table. And this kind of follows the normalization rules, right? Because we're not storing, like, the author's name in the books table.
Right. The author's name is only stored in the authors table. And the book authors table just links the two together.
Okay, cool. So that's a good example of how we can apply normalization in the real world.
Yeah, it's a common pattern in database design.
Okay, so now let's switch gears a little bit and talk about, how people might encounter these SQL concepts in, say, a job interview.
Okay.
So we've got some sample interview questions here that we can go through.
Sounds good.
So the first one is, what are the different SQL data types and when would you use each? So we've already kind of gone through the different data types.
Right.
But how would you answer this question in an interview?
Well, I would start by listing the main categories of data types. Numeric, character, date time, Boolean, and binary. And then I would give a brief explanation of each category and some examples of when you might use each type.
Okay, so, for numeric, you would talk about int and decimal and float and explain, like, when you would use each one.
Exactly. And for character, you would talk about varchar and char and text-t, and so on for the other categories.
Okay, cool. And then the next question is, what is the difference between a primary key and a unique constraint?
So the main difference is that a primary key cannot be null, whereas a unique constraint can.
Okay. And also, I guess a primary key is used to uniquely identify each row in a table, whereas a unique constraint is just about making sure values in a column are unique.
Exactly.
Okay, cool. And then another question is, explain the different normalization forms with examples.
So for this one, I would just briefly explain first, second, and third normal form and give a simple example for each one.
Okay. So like for first normal form, you might use the example of the students table with the subjects column.
Exactly. And for second normal form, you might use the example of the orders table with the product name column, and so on.
Okay, cool. And then how do you enforce data integrity in a database?
Well, the main way to enforce data integrity is through constraints, which we already talked about. So,
Okay.
primary keys, foreign keys, not null, unique, check.
Exactly. All those constraints we talked about.
Right.
Okay. What are the trade-offs of normalization?
So the main benefit of normalization is that it reduces redundancy and improves data integrity. But the downside is that it can sometimes make your queries more complex and slower because you have to join more tables together.
Right. So it's that trade-off between like having the data perfectly organized versus having efficient queries.
Exactly.
Okay. What is a composite key?
A composite key is a primary key that consists of multiple columns.
Okay. And we saw that in the book authors table.
Right. The bookid and authority together formed the primary key.
Okay, cool. Um, how do you add a constraint to an existing table? So, we have an existing table, we've already defined it. How do we actually add a constraint to that table?
You would use the alter table statement. So like to add a unique constraint to the email column of a customer's table, you would say alter table customers add constraint, unique mail, unique email.
Okay, got it. And then what is the purpose of the check constraint?
The check constraint is used to enforce specific conditions on the values in a column. So like we talked about earlier, you could use it to make sure that an age is always greater than or equal to 18.
Okay. What is the difference between varchar and text?
So varchar is for storing strings of specific length, whereas text is for storing large blocks of text.
Okay, so if we know the maximum length we'll need, we'd use varchar. If it's like a whole article, we'd use texty.
Exactly.
Okay. How do you handle enl values in SQL?
You have to use the is, el, and is not nello operators. You can't use the equal sign or the not equal sign with nulls.
Right, so you can't say like where email equals NL. You have to say where email is NL.
Exactly.
Okay, got it. What is a self-referencing foreign key?
A self-referencing foreign key is a foreign key that references the same table.
Okay.
So like you might have an employees table, and there's a managered column that references the employee column in the same table.
Okay, so we're saying like this employee's manager is this other employee in the same table.
Exactly.
Okay, got it. What is the difference between drop and truncate?
Drop completely deletes the table, including the data and the structure.
Okay.
Truncate just deletes the data, but keeps the table structure.
Okay. So if we want to get rid of the table entirely, we use drop. If we just want to get rid of the data but keep the table, we use truncate.
Exactly.
Okay, cool. How do you remove a constraint from a table?
You use the alter table statement again, but with the drop constraint clause.
Okay, so it's similar to adding a constraint, but we're dropping it instead.
Right. So to drop the unique mail constraint, you would say alter table customers, drop constraint unique mail.
Okay, cool. What is the purpose of the default constraint?
The default constraint is used to specify a default value for a column. So if you insert a new row and don't specify a value for that column, the database will automatically use the default value.
Okay, so it's like a fallback value for that column.
Exactly.
Okay, cool. And then the last question here is, what is denormalization and when would you use it?
Denormalization is basically the opposite of normalization. It's where you intentionally add some redundancy back into the database.
Okay. But why would you ever want to do that?
You might do it if you need to improve performance. Sometimes having the data spread out across multiple tables can make your queries slow. So you might denormalize the data a bit to make the queries faster.
Okay. But we have to be careful, right? Because denormalization can lead to inconsistencies.
Exactly. You have to carefully weigh the trade-offs.
Okay, perfect. So we've gone through all these interview questions. Why don't we do a couple of scenario-based questions?
Sure.
So first scenario, we need to design a database for a school. How do we make sure that the data is accurate and we don't have any redundancy?
Well, we would definitely use primary keys and foreign keys to link the different tables together. And we would normalize the data to at least third normal form.
Okay, so like we might have a student's table, a teacher's table, a courses table, and then we would have like a student courses table to link students to the courses they're taking.
Exactly.
Okay, and then we'd use primary keys and foreign keys to make sure everything's linked up correctly.
Right.
Okay, cool. Second scenario, We have a customers table, and we need to update the email address for a specific customer. How do we do that?
You would use the UP date statement.
Mm-hmm.
So, like, to update the email address for the customer with customer5, you would say UP date customers set email, new mail at example.com where customer is 5.
Okay, perfect. So I think we've covered a lot of ground here.
Yeah, we've gone through data types, constraints, normalization, and even some interview questions.
Exactly. And hopefully our listeners have a better understanding of these fundamental SQL concepts now.
Yeah, this is really the foundation for building good databases.
Exactly. And in our next deep dive, we're going to be talking about CR-RED operations and basic queries in SQL.
Yeah, so we're going to actually start working with the data and seeing how to retrieve and manipulate it.
Exactly. So if anyone has any questions about what we've talked about today, or if there are any SQL topics that you'd like us to cover in the future, please feel free to reach out.
You can find our contact info on our website.
Exactly. So thanks for joining us for this deep dive.
Until next time.
And one final thought to leave everyone with. We've talked a lot about organizing data in databases. But these concepts of data types, constraints, and normalization, they're not just limited to computers.
Mhm.
Think about how you might apply these same principles to organizing information in your own life.
Yeah, like how do you categorize your books? Do you have any rules about how you file your documents?
Exactly. These same principles can help you organize anything, whether it's physical objects or digital information.
It's all about making the information more accessible and useful.
Exactly. So think about that, and we'll see you in our next deep dive. Bye!